Alright, on this video we're going to be covering translations, which is one of our transformations that we have to cover in Math 2. With a translation, you might also hear it called a slide. It is a transformation in which every point of a geometric figure, so it's any shape, is moved the same distance in the same direction. This is called a congruence transformation, because if I take a shape and I move every single point the same distance in the same direction, then my result would be a congruent figure to the original. I know I didn't do a good job sketching that, but every side would match up and every angle would still be congruent. So that's the reason why it's called a congruence transformation. A vector will describe the direction and magnitude. You use these kind of corner brackets right here to denote it, so it kind of looks like a coordinate, where A will represent your horizontal change, that's your left and right, and that makes sense. It's first. It kind of lines up with what X typically is in a coordinate. Typically in a coordinate you'll have your X value and your Y value. B represents the vertical change, so that kind of lines up with your Y value in a typical coordinate. So now in example 1, we're going to describe the translation 4 units to the left and 3 units up using a vector. Now first I'm going to actually make a sketch of what this would look like. So if I have point A right here, and I'm going to go 4 units to the left and then 3 units up, my new point would be translated to right here. We would call this A prime. We'd denote it with an apostrophe. Alright, so now think of this as your origin, more or less, and this is your new location. So if I were trying to describe what this vector was, I would denote it with the little corner bracket. Since it went to the left 4 units, that's a negative direction to the left, just like going down is vertically. So that's negative 4, and since it went up 3 units, that's going to be positive 3. And this is describing the translation. So in this next problem, I'm going to take a point and I'm going to translate it 2 units to the right and 5 units down to a new location. And here's my vector that I'm going to describe. So this one is kind of flipped from the previous example. So here, since we went to the right, my horizontal movement is positive. So it's positive 2 for my horizontal movement since it was going to the right. On this one, the vertical change was going down by 5 units. Since it was going down, that's going to be a negative value for my B. So 2, negative 5 describes this vector, which describes the translation. So really these are just extensions of the previous 2 examples. So if I'm going to describe the translation from B to D, traveling from B to D, I'm having to go up and to the right. So both of my values are going to be positive. So this translation is going to the right 1, 2, 3, 4, 5, 6, 7 units. So positive 7 is going to be my first value in the vector. And since the vector went up from B to D, that's going to be positive 2 right here. Now, it's really easy to get crossed up, because if the problem had been from D to B instead, these would have been negated. It would have been negative 7, negative 2. So you really have to pay attention on what point you're traveling from and which point you're arriving at. So on part B, which is a different problem, name the vector for the translation from E to C. So we're going to go from E to C. That's to the left and down to achieve that translation. So since it went to the left 1, 2, 3, 4, that's going to be negative 4 since E is my starting point. And then it went down 1, 2, 3, 4, 5. So negative 5 is my B value for the vector. Alright, that wraps up that example. So up till now we've been dealing with individual points, and here we're actually going to deal with a shape. So I'm going to go ahead and plot these points. A is the coordinate 1, 1. B is the coordinate 2, 4. So you start at the origin, to the right 2, up 4. C is 3, 1, so 1, 2, 3 to the right, up 1. And D is 4, 4. 1, 2, 3, 4, 1, 2, 3, 4. This is actually a parallelogram, is what this would be called. So I'm going to go ahead and connect the dots here to make a nice little shape. Now I'm going to graph its image after the translation has occurred. The translation that they're giving me is described by the vector -3, 2. So what that means is I need to take every single point and go to the left 3 since it was negative and up 2. So point A will go to the left 3, 1, 2, 3, up 2. So here will be my new A prime. I'm going to do that the same for each of them. Now remember, I'm not going to go from where A was. Now I'm going to go from where B was when I go left 3 and up 2. So from B, I'm going to go left 3, 1, 2, 3, and up 2. So here's B prime, the new image. The reason why I'm doing left 3 and up 2 again is because that's what the vector said to do. So I'm going to do it for C, left 3 and up 2. And for D. And I'll connect those. Now what you're going to see is an image where it is congruent to the original. Just every single point has been translated to the left 3 and up 2. I did ask to list the coordinates here, so my coordinate A is -2, 3. Which could have been found, by the way, by just doing 1 minus 3 is -2, 1 plus 2 is 3. And now I can do the same for B. So 2 minus 3 is -1. 4 plus 2 is 6. And -1, 6 does match up with what I have graphed there. For C prime, it's going to be 0, 3. And for D prime, it's going to be 4 minus 3 is 1. 4 plus 2 is 6. And there's my final answer for that example. So the last thing I need to talk to you about is a vector can sometimes be written instead as a rule. The rule here is x minus 3, y plus 7. That would match up with the vector -3, 7. Because you're going to take every x value, you're going to subtract 3 away from it, like I did on the previous example, and you're going to take every y value and add 7 to it since it's going up. So here, to describe this translation, x plus 6, y minus 10, that would match up with the vector +6, -10. So this is a rule, this is a vector. Just depends on what they ask you for, so just be aware of these two terms up here. Now if you wanted to describe it, you could say a translation right 6 units and this went down since it was negative 10 units. Alright, that completes the lesson. I appreciate it.